So we wanted to study the effects of increasing milk prices on demand of milk in corner shop in Bayswater area of London. We found that our population of interest, corner shop in Bays area, contained only 43 units. Because we wanted to have a sample as large as possible, we collected information on prices and demand for all of these shops. The estimated coefficient for the elasticity between price and demand was 0.3. Since we gathered information on all the population, our sample was not random, and we cannot consider our OLS estimator a random variable either. Discuss. This is a very interesting question in some levels because it can highlight bits that you haven't quite understood very well. Okay. In here, the population was completely sampled. Agree? Does that then mean that our beta hat is non-random? A lot of students will be inclined to say yes, okay, that we've collected the whole population, beta is not random. However, what they're forgetting is this.
Population is also random itself.
Population is also random itself. That epsilon, right, that you have, when you build up a model, so the A1 assumption tells you y is equal to beta 0 plus beta 1 times x plus the error term. This error term here is random, right? This error term here is random because there will be other things that affect the demand of milk beyond its price. The availability of substitute products, the weather conditions, all sorts of things, demographic in the neighborhood and how those demographic in the neighborhood change, etc., etc., etc. So this error term here is random, which means if you go to those 43 corner shops again, right, and you collect data again for them, you are going to get different data and you're going to get different beta hats, which means that our OLS estimator is random, okay? Because the data generating process will be random. Now, also note one thing, okay?
It's more about saying that than what Bjorn said, saying that the population is itself random.
Yeah.
We can say both.
Well, they're equivalent, right? What you're saying is that the population, which is this data that you're collecting yi, is random due to the random nature of the error term, right? So the population is also random. Okay? Which means that you're not, every time you collect data, the only way that the OLS estimator could be non-random is if both the x and the y are exactly always the same, right? That's the only way you're going to get the non-random OLS. If OLS changes, if the data set changes, then you're going to get a different OLS, which means that the OLS estimator will indeed be random, depending on your sample. Also note one thing. What will happen, or let me ask you a different question, is beta 1 hat or the OLS estimator biased or unbiased? What do you think? Imagine that I changed this question, I told you something. Since we gathered information for all population, our sample will lead us to an unbiased OLS estimator. Discuss. Yeah. Of course, your answer should have been, it depends on what's epsilon and whether your A5 assumption holds or doesn't hold. So sometimes, even if you collect the whole of the population, right, you might still get biased results or biased coefficients, okay? So that's question 2.